Guys, so in this lecture we are going to look at the L3 practical. Now the L3 practical is the practical for also the measurement of refractive index, but this time they use the triangular glass prism. Now the other ones we'll be working with are the ones where they use the rectangular glass prism, but this particular one, what they use is the triangular glass prism. So we are going to look at it now, and we are going to see the questions that follow suit. It's a very simple something. Now we have the first question here. It says plot a graph of D against I. That is D, the minimum, the deviation against the incident angle. Alright, the deviation against the incident angle. And I believe all of you measured these values and you have your values already in your manual. Now, like I told you, that the intent is not for you to copy what we have here, but the intent is for you to use this as part of your work, to guide your work and your working. So we are going to plot a graph now of D against I. So let us go to the graph section. Alright, so we are going to plot the graph of D against I. So what will happen is that D would be on the y-axis and I would be on the x-axis. So what do we do? First of all, we have to draw a straight line, right, to represent our axis. So we'll have a straight line. Now, as a matter of fact, this is going to give us a curve. Are you getting it? A curved graph. So have it at the back of your mind that the graph you are going to get is going to be a curved graph. All right, having done this, the next thing we are going to do now is to write out this thing. So here is 0, 0, and then let's take a scale. The highest values you have on D is 51, while the highest value you have on I is 60. So for D, can we go, let's not go too far, let's go with 1 centimeter to 10 units, or 2 centimeter to 10 units. Will it work? 1, 2, 3, 4, 5, 6. Okay, to work. So let's say, first of all, you have to write a graph, all right, of D degree against I degree. All right, now scale, let 2 centimeter be 10 units on will it work on both axes? On both axes, will it work? 2 to 10, that is 12. Let me check our graph here to see if it will work. 2 to 10, that is 12. So here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it actually worked. So you say 2 centimeters and be 10 units on both axes. All right, on both axes. Now you can actually start from the one you want to, but the values you have here, the lowest value you have here is 30. You can start from 30, the numbering from here, but most of you will say, you don't understand that one. No. So let's start from 10. So here will be 10, here will be 20, here will be 30, here will be 40, here will be 50, here will be 60, and then lastly here will be sorry about that, here will be 70. All right, so that's the value you have for that. Now the next one is the one you have under here. Let's label on write out our this thing values here. Here will be 10, here is 20, here is 30, here is 40, here is 50, here is 60, here is 70, here is 80. So what graph are we actually plotting? We are plotting a graph of D against I. So when D you can come here and say d in degrees. So sorry about that. You can come here and say d in degree. This is the y-axis, and then this one I in degree. This is the s-axis. Alright, so let us begin our plotting. If we want to begin our plot, I would love to take this one this way. Then let's plot. Now when d was 51, I was 30. So we have here as 50. 51 will be a little bit ahead. Then I was 30. Was d was 51, I was 30. So we have 51. I here is 30, which is somewhere around here. Is that okay? Now when d was 32, I here is 40. When d was 32, I is 40. Are you sure they ask us to plot a graph of d against I? Sorry about that. Plot a graph, yeah, d against I. So we come here. When d was 32, I is 40. Is that okay? So this is our d is 32, which is above 30 a little. I is 40. So we have 40 is here, right? D is 32. So 40 is here, somewhere around here. When d is 45, when d is 31, I is 45. When d is 31, I is 45. So d 31 somewhere around here. Yeah, d is 31 somewhere around here, a little bit below 32. We can decide to place this one here and then place 31 just here. I is 45. This is 45. So when d is 39, I is 50. So we have 50. 39 is very close to 40, which is somewhere around here. I is 50. When d is 45, I is 65. D is 45. This is 45. I is 65. This is 65 here. Because okay, this is 60. So 65 will be somewhere around here. So 45 to 65. So this is the kind of graph you are going to have. Now when you draw this, it's going to give us a curve. I don't know how we are going to draw this curve, but it's surely going to give us a curve. Let's see if we'll be able to draw this with this stuff here. Okay, let me just draw it first and then arrange it later. Alright, going to give us a curve like this. Is that okay? You're going to give us a curve, because this practical normally, like I told you, is going to give us a curve. Now the next question, the question you have here is to calculate your d minimum. Calculate your d minimum. Now how do we get the d minimum? It's very easy. Alright, and the corresponding angle of emergent angle. So d minimum is the point at which this whole thing here is lowest. That point at which this curve here is lowest is our d minimum, and our d minimum here is around 31, because it was 31 that we drew at that point, right? So if we draw a line to this side, we have our d minimum to be around 31. Most time the lowest value you have on the d axis is your d minimum. So our d minimum is 31. The corresponding angle of emergent for the d minimum is 40. Are you getting it now? So that is that. So we'll now come here 45 rather. So we'll now come, the question say from the graph determine the minimum deviation. The minimum deviation is that angle that angle we determine here, which is 31. So you now come here and say minimum deviation is 31. So you can come here and write d minimum, my dear student, is 31 degree. Are you getting it? The corresponding angle of incidence. What is the corresponding incident angle? This is our I, which is our incident angle. For d minimum, what is the corresponding incident angle? Is 45, ID minimum. So we have 45. So we have ID minimum, corresponding angle for minimum deviation, 45 degree. Are you getting it now? So if you come here, you say d minimum is 31 degree, corresponding minimum deviation angle 45 degree. Is that okay? Exactly. So that's what we have for this one. All right, is there any other thing we need from this graph again? I don't think. All we need is are there comments on your result. Now come in before we comment. Now the next point we have here is comments on the result, right? Now if you want to comment on the result, these are some comments that you can actually make. You say, from the result obtained, the minimum deviation refers to the smallest angle by which a ray of light is deviated when it passes through a prism. It occurs when the incident angle and the refracted angle are such that the deviation is minimum. Minimum deviation is usually denoted by what? D minimum. The symbol is D minimum. Are you getting it now? From this experiment, this is now what you are going to write to in accordance with this, in addition with what you have here on your screen. You are now going to write, from this experiment above, the minimum deviation from the curve is 31 degree, and the corresponding angle of incidence for the minimum deviation is 45 degree. Are you getting it? Then you are now going to continue writing on the incidence angle. The angle of incidence that results in minimum deviation is often denoted by the symbol ID minimum. For a prism, the angle of incidence that gives minimum deviation is typically less than the critical angle. Beyond the critical angle, total internal reflection occurs, and the prism behaves as a retro reflector rather than a refracting element. So these are some of the comments that you can actually make under the this thing that says you should make a comment on this particular practical. All right, so that is that. Now the next one is calculate the refractive index of glass material using the equation. The equation is N. Let's write out the equation. N is equals to sine A plus D minimum divided by 2, all divided by sine A over 2, where A in this case is the angle, and the sides of the angle of a triangle is 60 degree. So A is 60 degree. Our D minimum is 31 degree. Are you getting it now? So how do we calculate our refractive index? N will be equals to sine A is 60 degree plus D minimum is 31 degree. Now D minimum is usually very, very correct when it's around 34, 35, 36. However, 31 is not that bad, but it's still going to give you a lower value. And then you have sine 60 over 2. So wherever you see D minimum here, what you do is to put in the value of D minimum we calculated for, which is 31 degree. Is that okay? So that is that. And then at the end of the day, our N will be sine 91 divided by 2, which will give us 45.5, I think so, because 60 plus 31 is 91 divided by 2, you have 45.5 divided by sine 60. I mean sine 30, because 60 divided by 2 is 30. I think that is the formula here. Alright, that is it. Alright. So that at the end of the day, This whole thing will now give us sine 45.5 divided by sine 30, and this will give us 1.42. So our n is 1.42. This is not bad. This is very okay, because the refractive index of glass is around 1.6, 1.5. This is very, very okay. Are you getting it now? So this is our n, and this is the refractive index that you were asked to calculate. Refractive index. Is that okay? That is that. Now, determine the error in n. Now, the error in n, how do you determine the error in n? N is made up of the minimum deviation and the angle A. Are you getting it? The minimum deviation and then the angle A. So most times, what you can actually do here is to find the error in the minimum deviation divided by the A is a constant, so it doesn't really have any error. So the only error we should be looking at now is the error in the minimum deviation. All right. Now, the other question you have here says, explain why it is not advisable to use small value of I in performing the experiment. Now, there are so many factors why you should not use small values of I. Now, one of the critical factors is to avoid total internal reflection. Is that okay? Total internal reflection. That is the reason why most times we don't use a small value of I. Now, in the same fit, you don't use the small values of I because of difficulty in measurement of angle. Is that okay? Because of what? Difficulty in angle measurement. But the most important reason is to avoid what? Total internal reflection. So that is the reason why you should not use small values of I. And I believe that is all for this particular practical. Now, in case you need to write so much on the reason why you should not use small values of I, you can just write this one. These are the reasons: increased sensitivity to experimental error, difficulty in angle measurement, greater influence of surface imperfections, limited range of applicability of Nernst law. You see the explanation, and then potential for total internal reflection. Of all the reasons, this potential for total internal reflection is the most valid. Now you can now write, at very small angles of incidence, especially when light is traveling from a medium with higher refractive index to one with lower refractive index, there's an increased risk of total internal reflection. This phenomenon can limit the measurement range and may not provide meaningful data for determining the refractive index accurately. So when you write that, you are very true with that practical. Thank you very much for your time. I think we will see in the next one. For the error in n, use the formula I gave to you, where I said the standard error is equals to W all over n, where W is the range 51 minus 31 divided by n is 5. 51 minus 31 will give us 20 divided by 5, which gave us 4. That is the only logical this thing, because it's a curved graph and you cannot get the vertical scatter. Hence, measuring the error will be very, very difficult. All right, so that's that for this particular practical. Let's see the next one.